In today's class, we will be talking about data structures. What do you mean by data structures? And by data structure is one of the most important topic in computer science. So what is data structure means? Data structure means how we represent data in memory. We have already taken up a couple of data structures. You must have, listening to what is an array, stack, heap, right? These are all different types of data structures. Means anyway in memory, in physically they are stored in some cells or something. But how is your program going to read that collection of cells is what data structure is all about, right? So your program, how you are writing the program to read the data, how are you we can say how are you representing that data in the memory? That is what data structure is all about. And how fast your program is depends how efficient your data structure is there, right? So we will talk about certain basic data types and how Java programmer does not have to really implement all these things in programming. Generally, what you must have seen that I was doing some insertion and deletion in linked list. But in Java, they have certain wrapper classes. Wrapper classes means certain classes which hide the basic coding. It just gives you an API to insert and delete. So you have to just call that method, add or insert or delete at a particular location. But internally, there is a program that is running which is doing the manipulation, just like how I was showing into this program, right? So generally, what happens is people who start their programming career in Java, they may not be able to write the code for the basic manipulation of data structures, but who studied computer science and who started coding in C and C++, they probably might be able to write such kind of codes. But for you as a QA, you don't have to write the code, but at least you should have a high level of understanding what are these basic data structures all about. Okay. So we have already seen used the data structures array. So what are the main key points in an array? Array is a fixed size, right? It stores data in continuous memory location. It stores homogeneous data. What do you mean by homogeneous data? So same data type can be stored in an array, right? And since it is fixed size, so the arrays cannot be increased or the size cannot be decreased also, right? So if means that if I define the array of 1000 elements and if I store only 500 elements there, so the memory space for 500 elements is wasted. That memory cannot be used by any other object or any other data in the memory, right? So it is not a very efficient way of using if you do not know how many elements you are going to store, right? So what happens is, I'll give you an example, a basic example. Let's say you are doing some testing. You are supposed to test W3 schools. When you are doing the testing, there are let's say 50 links, right? So your expected number of links is 50. But you don't know what is the actual link, right? You cannot fix the size. It might be more than 50, it might be less than 50, it might be, So if you keep the array size as 50, so if there are more links, probably your program will crash, right? Similarly, if you have less number of links, the memory space there would be memory space which is unutilized, right? So there are certain Java has certain API which is called collections API. Collections API, which actually gives you a very easy and convenient way to manipulate arrays. And there are certain other data structures also. So first let's look a brief introduction to all the basic data structures, and then we will come to the collections API. So arrays, as we have seen, it's a fixed data type where elements are stored in contiguous memory location. Then we have stacks. Stack is a data structure where the element can be inserted from one end, inserted or deleted from one end. We call in stack insertion the element, the end from which the element can be inserted is called top. So we say top of the stack. Please try to remember these terminologies and use these terms when you are talking in your interviews. So we always deal with the top of the stack. The operation used to delete from stack is called pop. Right? So pop of the stack, and when you say insert into stack, this operation is called push. So you pop the top and you push onto the top. Okay. So let me show you the implementation of a stack in Java. So why I'm showing is probably you may not have to write the program, but at least you will get a good idea. Stack implementation in Java. So I can implement stack using the arrays also or linked list also. So before discussing linked list, so let me tell you what does linked list mean. Linked list is always compared with arrays. Why? Because linked list is also used to store the data, but you don't have to store the data in contiguous memory location. So it can always, your program can always utilize that scattered memory space, right? So it is more efficient when you do not, because you don't need a large chunk of memory to store the data. It can use any part of the memory that is available. So that is, it is more efficient in such way. But what happens is, so here linked list you would say the key points is no fixed size, means you don't have to predefine the size of the linked list. Second thing is the elements may not be stored in continuous locations, right? And you can actually here store different type of data also. Like it's linked list is a you can say it's a general data type which does not so you can define, you can create your own linked list which say, let's say you create linked list of objects. That object can be anything, right? That object can be a string object, that object can be any object, right? Similarly, like although when you define a basic linked list, it doesn't have to be same data type, it could be a different data type also. Okay. Then stacks and other data structures like stacks, heaps, these can be implemented using either arrays or using linked list, both. So these are the, you can say, base data structures. Arrays and linked lists are the base data structures, and they're the base data, another base data structure is heap. I will show you heap implementation also. What is heap? Heap is one of the you can say fastest and most efficient way of storing data. Heap data structures, and let me show you some images. In Java, do we use heap? Yeah. No. In Java, you cannot, you don't have pointers, means you do not have the access to the exact memory location, but internally definitely it is using pointers, right? Like when we say object is pointing to the heap, so there is a memory address, but in Java you cannot directly find the exact memory address. In C++, you can even print the memory address. In Java, you cannot do, because in Java programs run in JVM, right? So JVM defines their own logic to organize the memory. So when you are talking about memory in Java, you are talking about the memory in JVM. You are not talking about the memory in the machine, okay? Because JVM is basically dealing with the hardware. But in C++, you directly reading and writing on the machine memory, and you can read and write the memory address also. So that's the reason we say in Java we cannot deal with the pointers, right? But in C++ we can deal with the pointers, okay? Heap is a data structures, like you can say what happens is heap can also be implemented in different ways. Generally what happens, it is there are certain kinds of nodes like left node, right node. Before heap, actually I have to talk about trees. So I know there are too many things for you. So there is arrays, stacks, linked list, trees, heap, and we have graphs. Trees is you can assume that tree is basically a data structure where there is a root node and there are branches of the root. So it is like an inverted tree structure. So if you see this, this you can say it's a tree, right? So different trees, like there could be, there are binary trees, there are binary search trees. I'm not getting into the detail, otherwise you will get confused. So sometimes the trees they can have multiple nodes. So binary tree is a tree where every node can have at the most 2 nodes, 2 childs. So if you see this particular node has 2 nodes, 2 children. This particular node has 2 children. This particular node has 2 children. So this is called a binary tree. Binary tree can have maximum, in binary tree you can say every node can have maximum 2 child nodes, right? Like similarly we have a heap also. So heap data structure, there is a typical type of a tree structure which is there in heap. Similarly there is a typical type of tree structures which is used in graph. So it is, you can say some specialized types of trees and trees are there as a heap and graph. Then we will be focusing on array, linked list, and trees you don't have to, but arrays and linked list we will be using a lot. Now let's come to the selection paper. We have queues also. Okay, I forgot about queues. Last thing is queues. So queues, as I said, is this. I think we took up it in this is first in, first out. Queues are last in, first out, and queues are first in, first out. So the elements, so you can say the insertion is always done at the rear and deletion is done at front. So just like it has top element, the queue has 2 elements, front and rear. Right? So stacks have top and front has, queues has front and rear. The insertion is always done at the rear. Insertion is done at the rear and deletion is done from the front. Okay. Now we can implement trees, heap, everything we can implement using arrays also. We can implement using linked list also. Right. So these are the two base. Even stacks can be used, implemented using arrays or linked list, anything. So you don't have to get into those things. Now let's talk about the APIs. Collection API. What does collection API mean? So as I've told you, initially when Java was not there, collection API actually was introduced with Java 5. Before that, you have to write your own methods, your own program to manipulate all these data structures, as we were doing in C, C++, other languages also. But with collection API, it defines certain classes which can easily manipulate. So this insertion, deletion, a traversal of the linked list. Let's say you want to print all the elements. You want to go from the first element to the last element. So everything you can do, like it's a very easy API. So the main APIs that you will be doing is the list API. We have set. Then we have map. And all these are interfaces. Interfaces means it gives you some common methods that are implemented in some other ways. For example, list is an interface, and list is implemented using either array list or linked list. Okay. All these collections, list and set, they are actually extended by the super interface, which is called collection interface. So I can show you the hierarchy also. It's a container object that represents a group of objects. So any group of objects, as we have seen, arrays is a group of objects, linked list is a group of objects, right? So collections is this interface is part of java.util package. So we have been doing java.util package. So last class also we saw java.util. So most of this is part of this java.util package. We have the collection interface. Set and list are sub interfaces of collection. Queue is, we generally don't use queue, so I will not be talking about queue in Java. I think I have never used queues. But maps, it is not part of the interface, but it is, in general, it is part of the collection only. But it does not belong to the collection interface. So superclass of maps is not collection. Okay. Then we have collection interface. It provides some main methods. For example, here we are talking about list and set. There are some methods called add all, clear, contains all, equals, hash code, iterator, remove all, retain. Add means you can add any element to any of the list, any of the collection. So the collection can be a list also or set also, but the method would be just the same, add. The implementation might be different, but you don't have to worry about the implementation. You just have to call the method. So let's try to define and create a basic collection using list and set. So let me talk about list and sets now. So as we have seen, the most common implementation of list interfaces, array list and linked list. Set has set is different from linked list in few ways. We will be talking about that. And this implementation is hash set, tree set, and there is something called sorted set also. And I would recommend you to go through tutorials point. It has a very brief and a very to the point introduction to all the collection APIs, and very simple programs also. So you can just simply go and copy and paste and run in your Eclipse. And here you can see the collection. See here, collection interface, list interface, the set, sorted set. The math is not part of this, but so these are the methods which are defined. So I'll go through a couple of them, and we will write also some programs. So you will see, like using these methods, the line number of lines in the code is drastically reduced. In just one line, you can write the a long program. So it is very easy to use, especially when you are we will be creating the WebDriver framework. You will be using a lot of collection. Okay, so here, before doing this, let's see what is the difference between list and set. List is an ordered collection. What does ordered mean? It means that we can access any element of the list using index. So did we use any other ordered collection? Array. Array is an ordered collection because we can access any element of the array using that index, right? And it also means that it preserves the order in which the element is inserted. What does it mean? Let's say I write here, let me create a simple program. I've already created utils. Let's write a method. So this method creates a list. Okay, so I'm writing public void create list, and here I'm using the array implementation. So I'm creating the array list because there are two implementations, array list and linked list. And here I would say list is equal to new array list. And it is part of java.util package, so you need to import the packages. And how do we add the elements? List dot. So if you remember, we saw this add, right? So simply you just write list dot add. Say I can add one here. Let me add 10. List dot add 20. List dot add 30. So I am adding 3 elements. So the order in which I am adding will be preserved. So when I am trying to print the list, it is going to print it in the same order. So let's try to print this. I am writing another method. And I can use for each for printing the elements. Here what happens is like list, as I have told you, can store any object. And one more thing is the difference between list and arrays. Arrays list any of the collection APIs. Any of the collection APIs does not store primitive data types. It only stores object data types. So that's the reason we have wrapper classes in Java. Because if I want to store int, so I have to use the integer wrapper class to store the object. Okay. So you can use the for each clause. So for say object O in list. This out O. So I'm passing the list and I'm just printing it. Here, it really doesn't matter what type of list is, like it could be an array list, it could be a linked list, anything. So I'm creating the array list, adding 3 elements and I'm printing it. So let's create a test. So I'm creating a JUnit test only. Yes. Test list 1. So what is the package org.junit? Okay, now I have to create an object of my list. My list, let's say L is equal to new my list and import it from utils. Now what I have to do? L dot create array list and L dot print list. And here in my print list, I am actually, let me just return the count. So int count is equal to 0. And here you can increment the count. Right? So what I will be doing here, I am okay. So L dot this should return. Okay, first is when I am creating this list, let me just return the list type only, and I would say return. So I'm creating the list and I'm returning it, right? And in this example, I am passing the list as an argument, and I'm just printing the elements of that. Yes, list is a data type, right? Data structure, you would say. So I'm retrieving. So my list, where say some list. And L dot print list, some list. And sorry, some list. And what it should return? Integer. No, it's print list is returning the number of elements in the list, right? And what I need to assert? How many elements are there? 3. So what I have to assert? Assert dot assert equals count, comma. So this is expected. So this is 3, and the actual is count. Right? Is this clear? And let's run this. Run as JUnit test. So if you see this, it has cleared. And let me see the console. So these 3 are printed, 10, 20, 30. Now, not only I can print this, I can also here all the three elements are integers, right? As I've told you that it does not allow primitive data types. Then how am I adding 10, 20, and 30? What is this process called? Autoboxing. Autoboxing. So although I'm writing 10, but it automatically is converted to an integer object, and then it is being passed to as an argument to the list. Now another interesting thing is, not only I can, in the same list, I can actually add a string object also. So let's run this again. My test should fail because now my list contains 4 elements, and if you see the console, it is printing the element, right? So I can actually add not only arrays and not only one data type, I can add a group of mixture of data types also in the same list. But this is not a very good approach or a good way of writing a program. Why? Why? Right now I am actually printing, and I can see, this is the 4th element is an string. Let's say you wrote another program, another method which does some calculations on this argument, right? So let's say you want to add 100 to each number. Can you add 100 to Sam? No, it doesn't make sense. So anywhere in your program that it can throw an exception, it will stop working. Generally, logically, we should always use a similar data types, because when we are trying to group an object, all the objects should have the same character, because otherwise create a different collection. Because when you are writing, it's either you have to check it all the time. Either I have to check that the element is integer, then do this operation. If the element is not integer, then do some other operation. But I have to write my own code, right? Compilers will not check, right? To make that compiler check that similar data types needs to be added here, we make this list as a generic list. What does generic mean? That generic means that at compilation time only that check would be made, so that even by mistake you cannot add different data types here. So to make it generic, what I'll say, let's say I want to add integers here. So I will write here integer, and I would write here integer also. So if you see here, now it is giving me a compilation error. I cannot proceed with until and unless I comment this, like I cannot use this. So I'm making it more specific. This is called, I will talk about generics in detail in later on. So what are we doing? We are parameterizing the data type. So this is here not only integer, I can make it a list of strings, list of students, list of any data type. But this way I am trying to make my program more comprehensive. Like my program doesn't have to worry about what type of element is coming is being added to the list, right? So we should never use generic we should not general list, we should not use. We should always use generic list, generic collection. Not only list, we will be using generic text, we will be using generic maps. Okay, so it is always, that's the reason. If you see this this line was coming up, right, when I was not making it generic, because it says it is more prone to errors in future. So always make it a habit to use generic collection. Now what happens is, here since it is this list is an integer list, here also I can write here that it returns a generic one, and here also I can write integer. And instead of object, what can I write here? Integer, right? Now This is the implementation of array list. I want to show you something. Let's put it a breakpoint here and run this test again. And here now I am debugging this. Okay. So if you see this is the array list that has been created. And expand this now. Initially, although every array list, when you don't give a size, we don't give a size, right? In linked list, we don't give a size. So what happens initially, an array of 10 objects is reserved for the initial array list. Now we can grow, we can keep on adding. As we grow, the memory JVM automatically keeps on adding the space. But the array list internally is again implemented as arrays only because our base is arrays. But we don't have to worry about the expansion or so what happens, JVM automatically picks all, let's say you keep on adding elements to the array list. So JVM program, the program which is maintaining this will take all the elements from that place. If it doesn't have more space, put it somewhere else, but your program will not be affected. But it becomes slow. Let's say I keep on adding. It will become slow, right? Because you're looking for higher chunks and your program does not know, how many elements are you going to add. So there are so many addition, insertions again and again that programs become slow. So what happens is, here if you see an object array has been created, so you keep on adding the object element. Let me expand this. So 0, 1, 2, 3, rest of them is null because we have added just 3 objects, integer objects. And if you can expand, you can see the value also. So it is very helpful. This debug mode, when you will be running your WebDriver scripts, this debug mode will be very helpful to know what is the exact value in your current object. Okay, so you can stop this and let's go back to the Java. Now what happens is, so this is another point that we have found out. Array list stores data internally as arrays, right? And then we said that the list is an ordered collection. You can access any element using index. So how can we access? So let's say I want to access, say here in this program only. This is the list. So I want to print second element. So second element is equal to list sum list dot get, just like an array index, right? So you can give 1. So this is your second element. If you run this, you can see here the second element is 20, right? So get can be used with any collection to, but not any collection, with only list collection, not set. Set is not an ordered collection. Lists are ordered collections. So whether you are implementing through array list or linked list. Now I will show you how it will do the same thing using linked list. So what I am doing, I am writing the same method, but here implementation I would give the linked list. Here I am writing create list 1, and instead of array list I am writing here linked list. Okay, and I'm adding again 3 integers here. I'm not changing any of the other because add is basically the method defined in collections, right? So for linked list and array list are inheriting those methods from the collection only, right? So the usage is still the same, only the implementation is different internally. I don't have to worry about the implementation as a programmer. Now what? Let me call this method in my test class. And instead of create list, I'm calling create list 1. Okay, and let's make it integer. No, generic type everything. So I'm writing here generic only, right? Anything. See, when I'm making in generic, any list can take different data types, right? The base is how they're represented as linked list, but list in general can take any data type, unlike the array. But when you are making it generic, you are forcing it to have the similar data types only. So that generic you can actually add to any of the selections. What is that? No, this is not sorted list. No. It's an ordered list. Ordered list means the way you are inserting the elements, that order will be preserved. If you will insert 10, first 10, then 20, then 30, then you will, when you iterate through the list, this will be, because if you see this, we saw in an array, right? The first element was 10, then it was 20, then it was 30. Similarly, let me show you how this is represented as internally in the so let me put an breakpoint here, and now let's run this test list 2. So just copy this and say run as JUnit test. Oh, okay. Debug it. Linked list in Java is implemented as doubly linked list, right? Doubly linked list means it has a forward pointer also and it has a backward pointer also, which means that when you have the list would be defined like this. It will have basically 3 types, 3 parts. First part, second part, third part. The second part is doubly linked list. This is the data. This is the pointer to the previous node. And this is the pointer to the next node. So the advantage of this is you can traverse forward also, but you can traverse backward also, because you know the address of the previous node also, right? When you are traversing in the single linked list, you cannot traverse backward. You can just traverse forward because you do not have the address of the previous node. If you want to traverse or the reverse a linked list, then you have to store the previous link address also. So this is doubly linked list. And in collections API list, if you implement it, give a linked list, it actually stores it as a doubly linked list. I will show you. Here, if you see this is the linked list that is created, and if you see this is the element, this is the next, this is the previous. The next means the next one, next node, pointer to the next node, and previous means pointer to the previous node. Okay, so let's add, and if you see here, the size is 1 because linked list grows. Array list is implemented as an array. The size is fixed, 10 objects. Here there is no size, so it will keep on increasing. So if you see this, now the size is 2, right? So if you see here the next node, this is the next node. And the previous address, if you see this, the previous address is 56. So this is your header address, 56. Got it? No, you will. It is ordered list. All the lists are ordered lists because it preserves the order. Sets are not ordered. So, so if you see, if I am printing here, see, we printed in the previous. It's the same order. It preserves the order. You can use the get method also to print the second element or the third element. But what happens is, in memory it is scattered, but still you can, it preserves the order. But there is a catch here. When do we do linked list? When do we use linked list? When do we use arrays, list and linked list? Now, what happens is, array list is implemented through arrays, linked list is implemented through linked list inside. Now, what happens when you want to just read the elements of an list, or like you want to go to a specific address, then arrays are very fast because they are stored in continuous memory location. You can, JVM doesn't have to traverse, it just calculates the address and reaches that particular element. But in linked list, let's say there is a linked list of 1000 elements. I have to traverse 500 elements. I have to traverse 499, right? Although I am not doing it, but somebody is doing it, right? Some program is doing it. So the traversal is really bad in linked list. So generally, 80% of the time you will be using array list only. But there are certain occasions when you will where linked list is very efficient. Let's say you have to insert at 500 position, right? When you say 500 position, if it is an array, then you have to move all the elements after 500 one space down, right? And make room for that one element, right? Then insert that element. But in linked list, what happens? You just traverse 500 elements, just change the pointer, and your job is done. So if you are structurally modifying a list very frequently, then use linked list. Otherwise, use array list. So most of your job, like as an QA, you would be using array list only. Okay. So this is a very popular and important interview question. What is the difference between array list and arrays? Arrays and array list. Then what is the advantage of array list over linked list? Or you can say in what scenario we should use linked list and in what scenario we should use array list. Okay, so you can write here, when we have to structurally modify a list, we use linked list. Okay. So in the linked list, if you see here, you can do the same operations. Like you can get the elements. So here we are printing the second element, right? So it's just the same thing. So you can see the console. Okay, not printing. See here, it's preserving the order 10, 20, 30, right? Because it's an ordered list. Now let's come to set. What does a set mean? Although we will be doing some other examples also, like here what we are doing, we are just printing the, creating some list and printing the list. You can insert, I'll show you the APIs. You can, instead of adding one element, you can add the entire collection into a list. So let's say you have a two list and you have to add the elements of list 2 into list 1. So what you can simply, there is just one line of code for that. So let me do this. Let me write a program. This method adds element of a list to existing list. So I'm passing a new list, and I want to add it into, let's say, into this list. This is your current list, right? Now I want to add all the elements which are present in new list at the end of this list. So what I can do is, after this I can write list dot add all, and here I can give the new list. Okay, and say return. And again you can make it generic here. So let's call this in this our JUnit program. So here I have to create a new list, right? So some new list and make it integer. Make it an array list, or it doesn't matter. You can add an array list or a linked list. It really doesn't matter. New list dot add. Say I'm adding 100. New list dot add 200. Right. So this is my new list. Right. Now I want to add this into that previous 10, 20, 30 list. So how will I do? Let me call this, create the object, and I would say L dot add list, and I will pass this new list here. Okay, and then I would print the list. Again, same thing. What should be the new count? And print list. Okay, this should be do you see this? 10, 20, 30, 100, 200. And the order is also preserved. Right? Okay. So I hope this is very easy to, manipulate. So it's even easy to manipulate with the arrays, right? Because in arrays, again, you have to write your own logic to insert, to delete, to remove, to sort. Here, there could be just one method, and you have to just call that method. So everything would be taken care of. So let me see, so clear means you are just removing all the elements in the list. Whether it's an array list or linked list, you are just clearing the entire list. And these are collection API methods. That means it is valid on set also. Only get which we use was specific to list because it's an order collection. In set we can't use get. We can't because it does not preserve that index. So we have to iterate through all the elements and then pick the one which we want. Okay. So contains means this would be you will be using very frequently. Let's say you have expected list of certain elements and you have the actual list. Then you have to compare these two lists. That the elements in the expected list are all there in the actual list. So you will be just writing the line that actual list dot contains bracket expected list. Right. So we will be using this in WebDriver scenarios. When we will be doing WebDriver, I'll demonstrate using this. Okay. Similarly, we have contains all. Contains will check for one element. Contains all will check for the entire list. That all the elements are present in one. And we did this program, this method in arrays, right? We did this in arrays. So if you use list, you can convert an array into a list and just write this one line of code, right? So I'll show you how to convert the array into a list. So the next method we will be doing is So this is you can write this as your homework. Write a method. This method takes two integer arrays and arguments. Arrays as arguments, and checks whether all the elements in array 2 are present in array 1. Okay, so you need to create the list, make it an array list, and then use the contains all method. Please do this as your homework. So far we have studied about list, which we say is an ordered collection because it preserves the order in which the element is inserted. Another thing is we can always add duplicates in list. That means I can add 10 and 10 two times and it will be considered as a separate element. So you can add duplicates also. It allows duplicates. Set is an collection which is first is unordered collection. Then it does not allow duplicates. So if you remember sets from your math classes, sets does not allow duplicates. It allows only one value for every element, right? So if there is any kind of a scenario in which you are not allowed to add duplicates, for example, let's say I'm trying to store a person's list of addresses. A person might have different addresses like home address, office address, a PO box number. So probably he has three addresses. I want to put it into a list. So in the list, duplicates are allowed. By mistake, let's say I'm using an application. I go to a company, I said register my address under my name. So that person adds the address. Now this, I go again, I forgot, what address. I try to give the same address. If the application has to find out, right, it has to tell us that the address is already there. Then only it will say that this address is already there, right? So for this kind of a scenario, what data structure you will be using? You will be using sets. Sets should stop you from adding a duplicate element. If the elements can be repeated or duplicated, then use list. So it does not allow duplicates. And the most common most common implementation is hash set. So let's try to create a class. My set class. And here I'm creating a set. So this method creates a set. Using set, it will be really easy for you to find whether an array contains duplicate elements or not. And if it is duplicated, what element is duplicated and how many times it is duplicated. It's really easy. I'll show you how to do that. Okay. So let's create a set. Yeah, so that's I'll show you. When you try to add the elements of an array into the set, it will stop you, right? That operation, add operation will fail. Then you can put it into a flag that for this element or add operation failed, that means this element is duplicated. Okay, so I'll give you an example for that. So again, we will use generic set. So I am using integer. And the implementation I am using is hash set. And again, it is part of which API, collection API. So what method should be used to add the element? Add, right? So what I'll say, my set dot add right? I am adding 3 elements here, and let's return this. Return my set. Okay. And similarly, let's write a corresponding method to print. So this method is going to return the int print elements, and let's say it is taking okay. And how can I use int count? The same logic, right? So I'm counting, and I use a for each loop, integer x in my set, and let's say here count plus plus, and sys out x, and return count. Okay. So let's create a test class. Oh, okay. I created this here. I need to add this here. So do you see that using JUnit framework, it's much easier to manage all the test classes, what we are doing, what we are testing. So in general, for one class, we write corresponding test class. So this is the same concept we will be using in the page object pattern. We will write one page class and we will write another test class to test that page. Okay. Not necessary, not necessary. You might have to write from the scratch. So in the interview, they might ask you this question, right? Have you created a framework from the scratch? So if you are that, I will tell you, or Sampath will tell you that what you should be your answer based upon your capabilities. For some people, we would say that you could say, no, I did not create. I just executed the test cases in JUnit and TestNG framework. For some people, I would say that you can go ahead and say that, yeah, we created. Okay. So I was involved in the teamwork starting from the scratch. It's too early to say anything. You never know. People do surprise us a lot of times. Test. Okay, so what we have to do is here again we'll create my set s equal to okay, and then we have to call create my set, and what does it return? It returns a set. And then what you have to call? You have to call s.print, and it returns an integer, say count. You can write actual count also. And what I need to assert here, assert equals expected is 3 and this is count. And okay, so let's first run this and then I will tell you. Do you see this? Is it ordered? No, it's not ordered. So you never know how it is going to print. Okay. Now I wrote one down. We can use it for clause and just iterate. We are just printing the elements of the set. What you can do is there is an iterator. You can create an iterator object. Every collection has an iterator object. There are two types of iterators. One is simple iterator, another is list iterator. The simple iterator goes to the next element in the collection. Element in the collection. Okay, see, it always goes to the next, and until all the elements are covered. List iterator can go backwards also. Let's say when it starts reading, it goes to the next element. For some reason, you want to still read the next previous element. So it has iterator. This iterator has next method. List iterator has next as well as it has previous. So let me just demonstrate one of those. So let's try to print the elements using the iterator. So how can I do that? Public int print elements, say here IT. So I'm using an iterator here. Int count. So I would say I'll create an iterator object. Iterator IT is equal to my set dot iterator. Java.util you need to, and this is again integer. Okay, so I will write here while IT dot has next. Then, so I can write here integer, say IT, say my int is equal to this IT dot next gives you the element value, like whatever the object is. That object will be copied into my int. So then whatever operation you want to do, you can do on my int. You want to print, you want to modify, you want to, just process that element any other way that you can do, right? So if you want to, let's say, just list out my int, you can do that. What is that? Yeah, I used in file operations, if you remember properties, when I created the entry set, so I use an iterator. So this is the has next. So it will keep on iterating until it covers all the elements in the collection, right? So this has, I use this for sets. The same logic is even for the list, you can use that. Okay. And especially with sets it is used because in sets you cannot say dot get. Dot get you cannot do. You cannot go to, because it doesn't preserve the order. Okay, and let's return this. Return count, and I have to just increment the count here. So it does the same thing. Print elements 1. Save this. IT. IT. And run this. There are some errors it says. Okay. So your assertion has been clear. So we are using iterator and we use that. So similarly, like you have a list iterator, so I'll show you the list iterator API. List iterator. if you don't understand how to use it, just Google, sample code or something, you will find. At least you will read the code and you will understand, how is it used. So here if you see here, has next is being used to iterate to the next element, right? So here it has previous. It starts reading from the backward direction. So it reads the last element and, go backward. So it starts from so if you want to print the elements in reverse order, right? So this can be used, list iterator. So this is an interview question. How will you print the elements of an array list or a set in reverse, not a set, sorry. List iterator doesn't work on set, only on the list. How will you print the elements of an array list or a linked list using the collection API? So you will say, I will use list iterator, right? Okay. Okay. Also, there are certain other questions. So let's do one very common interview question. The question is, find the duplicate, or I would say find the unique elements from an integer array. How would you do this? Now, you have an integer array. So your program, what is the arguments of this method? Say, let's say you want to return an integer array which contains only the unique elements of an array. So your input is, let's say your input is an array like this, 1, 2, 3, 1, 2, 3. So the output, the return should be 1, 2, 3. This should be your output array. Okay, how can you do this? Using set, it would be very easy to do this. What I'll do, public int, say find unique, and I will pass the integer array here. And what is my return type? Integer array, right? So let me create an integer array, say new r, and new int, and what should be the size? Let's because we have to put some size, but it would never be the greater than the size of the input array. So I can use add.length, right? And return new r. Now what I'll do, I'll convert this array into a set. So what I'll do, I'll create a set of integer s is equal to new hash set, and then I'll keep on adding. So for the entire collection, so I would say for int x in add, what you do, s dot add. Now if you see this s dot add, what does it return? It returns true if it successfully adds the element. It returns false if it is not able to add the element. And there will be that false. If it is a duplicate, it will not be able to add. Okay. So what I will check, I will say if s dot say add, say s dot add, what I am trying to add is x is not equal to true, or you can say it's not equal, it's equal to false, then what does that mean? it's a duplicate. So you can actually put a flag here, say Boolean flag is equal to false. If s dot x is not equal to true, then you can if you want you can print a message. Say you can say x plus is duplicated, and you can say initialize is as a true, and here you can say flag is equal to false. So what I'll do, I'll create and I'll if flag is false, now what I'll do? Okay, here what I'll do. Okay, so I need to first, if flag is equal to false, so I keep on adding. Okay, fine. So now this array, so this S would contain all the elements which are unique elements. So once I am adding keep all of these, so it will contain all the unique elements. So I don't have to actually do this for flag, because I'm not dealing about the duplicates. I'm dealing about the unique elements. I don't have to do that. Now I have to convert this set into an array, right? So how can I do that? We have an API called, so every selection can be converted into an array. So I would write here new ar is equal to s dot to array, and it actually it converts into an object array. Then I have to convert it into an Can I convert into an integer array? Okay. And here let me put it into an integer array. Okay. And here it would be new integer. Okay. So what I'm doing here, I created an integer array. I kept on adding the elements, and I'm just printing whichever it is duplicated elements which are unique. So after everything is covered, so S will contain only those unique elements, and I'm converting that new S2 in an array, and I'm returning that array, right? So let's try to test this. Now tell me the test cases for this. How will I test this particular method? Any ideas? Try to add existing elements. Okay. What I will do, first I will create an array. First I'll pass an array. So array I am passing. I know how, what is the exact number of duplicates there. So I can compare with the count. So what I'll do, I'll say s dot, what is that method? Find unique, right? And here I'm creating an integer array. And here I would say 1, 2, 3, 1, 3. And it should return an integer array, say unique, right? And now what I have to assert? Assert dot assert equals expected. What is expected? Uni dot length. So this is your expected. No, it should be in actual. Uni dot length, and here I would write 3, right? This I need to test. So see, this is the trick. Whenever you are writing, you should know what is your expected value and what is your testing, right? So the return type of the calling method is also very important, because whenever you are doing API testing, a lot of times you may not have the access to the code. What you have access? You have access to public methods only. So you can test an API only using the public method. So you can test only what is, you will be giving the different sets of values for the arguments, and then you will say, check for the return type. Then my question is, how will you test the void? Let's say there are methods which have return type void. How will you test? No, you cannot print anything. You cannot change the source code. The source code is already given by the developer. It's written. You cannot change that code, right? So void methods, you cannot check for the return type value, but still you can check for some exceptions, null pointer exceptions, or any other exceptions you are testing. Similarly, my question is, when you are doing API testing, how would you check private methods? You need to test an API, like if a class, let's say a class, I would call a class. A class has public methods also and private methods also. When you are testing an API, you have to test both, right? How would you test the private methods? Because you cannot call the private methods in another class, because it's outside the scope. Whenever you are creating a private method, anywhere in your public methods or private methods are called. Otherwise, what is the purpose of private methods? Because there is some logic inside any of the public methods where you are calling that private method. So you have to write test cases on that public method to test the internal private method. You cannot directly test private methods. Okay. So the flow of the program you need to know. Now let's test this. Oh, here we don't have the unique element is 0, right? There is all the 3 elements are repeated. So we have to assert that 0 and yes. So the length of this array should be 0. Okay, cannot cast. Just give me a second. One, 2, 3 is duplicated. Let me just return just the length of the array. So int, and here also let me just return s dot size. Let me change this logic and then I can test it nicely. Int count, and now I have to test this count is equal to 0. Okay, and let me just add one more. So it should have 1. So the count should be 1. Still expected 1, but was 4. Okay, it's oh, it's adding all the elements. But once it is added, right? Okay. I have to put a flag. Boolean. Okay, I did not do the contain. Oh, I got it. So I'll tell you one thing. What is happening here? The element is added once, right? So this contains one entry for all the elements. So it contains the array 1, 2, 3, 4. So my S contains 1, 2, 3, 4. Right? This contains 1, 2, 3, 4. Now what I have to do, my question was, I have to find the unique elements from the integer array. So here what I can do is, when I need to put a flag here, Boolean flag is equal to true. Yeah, that I have to do. And here, if it is duplicated, put that flag is equal to false. And here, what you will say, keep on adding flag is equal to false. If say, let's say, flag is equal to true, but it will only check for the last count, right? Just remove the element, but if you want to store how many times an element is duplicated or how many times, then you have to use map. We will do that when we will do map. Because
okay, this was exact.
Yes. So your map will contain something like this. Your map would be like this. So let's say there is element 2, 2, 3, 4, 5. So you will be storing in map like this. 1, 1, 2. 2 is stored 2 times. 3 is stored 1 time. 4 is stored 1 time. And 5 is stored 1 time. So this is the key value pair you will be storing, and then here you will be looking for elements which has just one value, and then you will be printing those values.
Right. Okay?
Yeah. So for this case, you have to actually use a map. So that we'll do in the next class. But using sets, at least what you can do, the question actually could have been manipulated like this. Remove the elements, remove the duplicate elements from an integer array. Right? Remove duplicate elements from an integer array. So
yes,
here
because set will store only unique elements. Yes.
Yeah. So here right now you can just change it to this. And yeah. So here the same thing that what we did last time. New ar is equal to s dot to array. And you will put a casting here for integer. And you will return the new array. Okay. And here, since now what you have to check that this element, the size of this element should be, array should be 4. And this would be an integer. Say new array, and this would be new array dot length. Right? Oh, how many? 1, 2, 3, 4. It should be 4, right?
One new array.
Return new array. Okay. Let me see the size. So what is the best way? Put a breakpoint and then run. Debug this. So it will tell you what elements have been added. First, it will not be added because it is false. First will be added, right?
Yes.
So you can see the set also. you can see the second will also be added. See, the size of the set is increasing. The third element will also be added. Now it is not true because it is repeated.
Yes.
Now they are repeated elements. Now it is incrementing. So I want to see 0, 1, 2, 3. So let me just convert the after how. I just want to print this. Let me print this. This out. This out S. So directly, if you actually you can print a selection S also. Like just you will write S. You don't have to do put it into an for each clue. It put it and I can print out the new array also. This out control space. How do we print arrays dot toString new array? So it will tell me whether it has converted it properly or not. Because my S is 1, 2, 3, 4 only. So it should be the length should be equal to 4 only. I don't know why it is coming failing here. It's not even printing, so it's giving some exception. Java.lang object cannot be cached to this. Not able to convert. This is the issue. Okay, the issue was not in the logic, it was in the conversion. So here I can return s.size int, and I'm returning here s.size. And here I would say this would be actual size, and this would be int, and this would be your actual size. Okay, so this is your set, and these three are duplicated, and this is your set. So what the issue was, it was not converting the collection to array. That's the reason the array size was not 4. So let me see. Yeah, so that was the issue. S.to array, it should convert actually.
I think the declaration statement was a little, there was some mistake.
No, I don't think so.
It should have been new array int, and we had just written new array equal to. Shouldn't new array int square brackets equal to?
No, I think this is fine. You are creating an array of integer objects, right?
Oh, here we have already created. Okay, I thought in the statement below. No. Okay, no, yeah, then it was fine. Yeah.
I just wanted to convert the S to
right.
Array. So let's say to array. I did this, but probably I think I have to use this one. And here I can say new array.
Yeah.
And then print this. There's so much of similar APIs, I always forget, how to convert from one collection to array, from array to this thing. So there are so many APIs.
Will we get all this only by experience, right? Using it again and again.
Yeah, if you use it again and again, then probably you will remember. Otherwise, it's hard to remember a lot of
Right.
See here, now it is printing.
Yeah, right.
Got it? And another thing is, since it is an integer array and we already defined the length of the array, so we were asserting the array length with the set. That was a mistake, because array length will always be the initial fixed length. So our assertion was wrong.
Oh, okay.
Right? So my array is first. The conversion was correct, but the assertion was wrong.
Wrong, yeah.
Because here it will always be 7 elements. Because we already initialized the array with this size.
Right.
Actually, what we should have done, instead of writing it here, we should have written it here.
Declared it afterwards, yeah.
Yes, and here we should have written it s dot size.
Right, s dot size, yeah. Then it will take the size of the current set.
Yes. Now it will take the size of the new set that has been created.
Right, yeah.
And then you can compare. So if I run this again now, it should give me the same size. Now it is same, right?
Yes.
And it is also telling me what are the 3 elements that are duplicated. Okay?
Yeah.
If we don't know how many elements are there in the array, here also we don't know how many elements are there. Here we are testing. When you are testing, you should know the expected element, right? What you are testing? You are testing a logic which is actually finding the number of unique elements in the array, right? You didn't write the code. The programmer is writing the code, right? But when you are passing this is the input data that you are passing. When you are passing the input data, you already know, this is the expected answer. So when you are passing the input data, that expected answer tester should know it, right? Otherwise, how will you test? Okay. So here, like manually, obviously, it is all. I did it. The expected count could be a manual, or in your real world, where should the expected test data should come from? From a test file, some Excel sheet, some CSV, some property file, right? Something should store the test data. Tester should know what is the expected value. In unit testing, a lot of times they will not give you. You have to find it by yourself. That's the reason unit testing, you need to go through each and every line, see what is the core logic of that and whether it is giving the exact result or not. Okay. So unit testing, nowadays testers, they hire testers, but most of the times they are done by developers only, because they know what is the exact input and what is the exact output. And no tester will document it. No tester, I can guarantee you, no tester will document it. Yeah, so it is hard, because tester will not tell you this is the API. So generally you will be doing API testing of the public methods. So public methods, you have a certain, set of predefined input, and there would be an output. Okay, let's say get count list or something like this. This is the input and this is the output. For public methods, definitely if they are using Java doc, there would be some kind of information. So you can use Java doc, just like let's say I am using say array list API. This is an array list. When your testers write their own API, they can generate a document like this. In this document, it will give you what is the parameter, what is the description of the element of the method, and what is the expected exception it is thrown. Okay, so this kind of API is automatically generated. So learn about this Java doc. So they write comments. They write their comments here. If you see here, we have when you create a new class, there's a prompt whether you want to create a Java doc or not. If you click that, it will automatically create a Java doc. You write your comments there, and it generates an document like this automatically with all the public methods and private methods that for that API. Okay. Set of values, right? Now if I have to store key value pair, right? Just like we store in properties file, key value pair, how will you store? So there is an API called Match API. This is not part of the collection API, but in general when you talk about collections, we use maps also. So maps are used, and there are actually a lot of implementation of maps. So you have hash map and hash table, and in your interviews, this is interviewer's favorite point of discussion. What is the difference between hash map and hash table? Even though they will never use hash table, but still they will ask. But anyway, so you should know the theoretical difference. Hash map and hash table. So both these, they store key value pairs. Hash table is synchronized, but hash map is not. So you have to write your own code to synchronize this collection. Then what happens is, since there are key value pairs, first thing is no key can be duplicated. Can be duplicated. Second thing is, for hash table, the values cannot be null, right? But in hash map, the values can be null. Okay? And in hash map, it allows one null key also. But hash table does not allow one key, any null key, right? Then let me write, and here we do not have add, we have the different API for map interface. So we have, let me show you. Here, if you see this, we have clear contains key, contains value, contains key. We have already used this in properties, right? So you can search in a map, like whether a key is present or not. You can search in a map whether that value is present or not, right? Then you can get the entry set. Entry set as a key value pair, like it will give you the set of all the keys, because keys cannot be duplicated. So it is always put into a set, because set cannot be duplicated. So let's try to create a map. So I'm creating a my map class here. Say create a map, and I'm returning a map. And here we have key value pair. So let's say I'm again using the key is a string. Say the key is an integer, and the value is a string. So I can give any combination, string, string, integer, integer, a double integer. So I can have anything, any object as a key and any object as a value. Again, this is a part of Java utils package. And let's say I'm creating a hash map. Again, you have to write integer, comma, string. And instead of add, what is the method here? put. If you remember, we use put in properties file. So you will write here my math dot put. And here the key is an integer, so I can write here. So I can write here. Right? So similarly, I can have add another. Right? So you can keep on adding any key value pairs here. And let's return this. Return my map. Right? Now, how will you print this? So let's say you want to print all the key value pairs. So I'm just repeating what we did in the last. So we have to first get all these keys, and then we have to get all the values. And if you use entry set contains both the keys and the values. So it depends on you what you want to find. So what we say, we will say count public int print map, say print key values, and I'm passing here okay. Int count is equal to say -1 or something, or you can write here 0. Return count. Now you can use let's use an iterator. So okay, so let me show you some few methods which are present here. You can use an entry set which will give you the entire key value pairs, right? You can use a key set. Key set will give you only the keys. Okay. So what you can do, you can actually we'll use the entry set. So what does it return? Always see the definition here. So it returns a set with an integer and string. So what I'll do, so this is entry, and here it will be an integer and string. Okay, so this is my set. My set. Now what we'll do, we will use the iterator. Iterator to iterate through all the elements, because I don't know how many elements are there. If I want to find the elements in a collection, which method I should use? Size, right? So here we don't have, so we'll say my set dot iterator. Again, you can change it to entry integer string, because we know we are making it generic. What I'll do there next, what I'll write here, it dot has next. And what is every element type? Every element type is of entry type integer string. So say element is equal to it dot next. Okay. Now let's say you want to print the keys and the values. So how would you write? So your key is this and value is this. So you can say you can write here, say key is equal to element dot get key, right? And then you can write here space value is equal to, what will you write here? Element dot get value. Okay. This is your key, this is your value, because in entry set you get both. And just save this, and let's create, we already have this, a unit test. So what will I write here? My map test @test click void test map 1. Okay, and here I'll create a class my map m is equal to new, and we have to call this import. Then what I have to do? M dot create map, and it returns me a map of integer and string. Say map is equal to create map. Then what I'll do, I would say map dot okay, so we have to print, right? So m dot print, and here I would write map. And we did not increment the count, right? So count plus plus. So how many elements are there? 2 elements. So this would be int actual, and then again you have to assert dot assert equals what is expected? 2, and this is actual. Do you see this? Key is equal to 1, value is equal to Sam, key is equal to 2, value is equal to this thing. So I'll just briefly go through the this print KB. I think put is clear, right? Put is easy to understand. You have the integer and value. Then you have print. What I did is I create the entry set. I call this method entry set, which returns me an entry set with integer and string. Okay, and it is a set because this integer are unique. Then I iterated using has next, and then every element is you can reach by calling method dot next. Which what is the type? The type is entry integer string. Right? So I created an entry integer string. Then from this element I can get the key, I can get the value also. Okay. There is an important question. We cannot have duplicate keys in hash maps, right? We cannot have duplicate keys. Now, let's say I want to store duplicate key. For example, I gave you an example. I have multiple phones. Like this is my one phone. This is another phone, right? So I have this type of scenario. What data structure I would be using for this? This is the key value. But here we have duplicate keys. How can I store this? No, but the list contains only one value. I have key value. List contains only single types of values, right? No. Anyway, we have to use map because it is a key value pair. Okay. Now what I will do, I will create a map with the string, and here instead of single, what I'll do, I will put a set. I will create a set of strings. For every string, the corresponding value is a set of strings. So how will it store? How will it store? It will store like this. So it will store like this. So when I'm writing, I will create a string. Say, I will create a set first. Say S1 is equal to new set. Yeah, so it doesn't have to be. I'm storing the value that's as the set. Value that's set, right? The key is just. I'll show you. Let me demonstrate. No, there is like here the key is the string. So the string will be storing Shilpi only, one string. The value is the set. So it can have 2, 3, 4. So tomorrow, let's say I want to add another phone number. I can simply add it like here. So let me write the code for this, because this would be actually asked in lots of interviews. Key. So this is we are storing multiple duplicate keys, right? We are storing using maps only, but we are storing duplicate keys. So when I'm saying element.get key value, so value would be the entire set here, not just one value. Okay. So let me create a map for this, and we will use the same method to print it. Public void duplicate keys. No, it cannot take duplicate keys. The values it can take duplicate values. The values is related. Key is always, see, when I am searching for Shilp, I can do, let's say, you have username is equal to XYZ. Your password is equal to X. You can password also I can keep XYZ. But when you are searching, let's say on a property, in properties, can I have two properties, username? No, I cannot have, right? So this is, but this is a situation that you should need to have two same keys. So how will you store? You will store it like this. In only one entry would be one key with the multiple values, right? So I can say create map 1, and this would be set of string. Let's say, let's make this also as a string. New hash map. Return my map. Okay. So what I'll do here? First, let me create set. So set S1 is equal to new hash set, and you need to create set of string. So you would say dot add. So this is my one, let's say this is my one phone number, and this is another phone number, right? Now what I'll do, I will say my map dot put. My map dot put, I would write here say Shilpi, and here I would pass S1. Right? So this is one entry. Let's say I want to store Sampath's phone numbers also. How will I? That will be a separate entry, right? So I will copy, let's say I will have to create another set for us because he will have a different set of phone numbers. So yes, S2, so let's say he has some other phone numbers. Yeah, any, it's a set, it doesn't have a fixed size. So you can add 1, 2, 3, multiple. You can keep on adding, right? And then you can write, say, my map dot put, and this would be, let's say, and here you would write S2, and this would be S2, right? So how many elements are there in the map? How many elements are there in the map? Two, just 2 elements. There is just 2 elements. It really doesn't matter. Like Shilpi can have 3 phone numbers also, right? So I can have 3 phone numbers also. And let's try to print this. How will you print this? Exactly the same code, only the generic will be different. Print KV1. Here this is a string, and here this would be a set of string. Okay, and similarly, like everything would change. Hash map. But I'm not duplicating. I'm not duplicating the values. Values I'm adding here. Here, I don't want to add the same phone number again and again. If there is a situation when where you can add, duplicate as a value, then put a list. There is no compulsion. Instead of creating a string set, make it a string list. If you want to allow, but here I want to store my phone numbers. It should not be repeated. Yeah, as values, obviously. You can use set and list. Okay, so let's try to call this. And here create map 1, and here create okay. So let's print this. If you see this, key is equal to Sampath, and these are 2 phone numbers, and here Shilpi 3 phone numbers. So we are adding lot of data in just one data structure. We are not maintaining different data structures, right?